Back again with the what I'm going to call a AV plug RF amplifier. Okay, what we have here is that worn out RF signal generator, battery powered. I'm checking the current coming in from the 9-volt battery that's powering it. We're sitting at hovering around 24.5 milliamps. Measuring the voltage. This is on a DC setting. There's still AC component in this signal that I can't measure. But across the LEDs, 1.7 volts, which lights it very brilliantly. Got a small antenna wire here that we're going to get to in a minute, but you don't need it. Although adding me into the circuit bumps the voltage up a little bit. And I'm measuring the output from the RF signal generator to an earth-grounded oscilloscope. So I've got the oscilloscope grounded here to the signal generator. I get a lot better, easier signal to measure. This unit is not earth-grounded, it's just running off the battery. So going up to the oscilloscope, and at maximum brilliance at around 100 megahertz, and unfortunately we can't see the signal very well, but that's 0.5 volt per division. I only have a 100 megahertz scope, so we're entering no man's land here on the scope. But you can clearly see that it's about 0.7 volt per division signal going on here. If I turn it up to actually max brilliance, we're sitting right at about 100 megahertz, and you don't see the signal anymore. As here, I'll back it off. You can clearly see the signal, and we're at pretty good brilliance. We're at 1.58 volt across the LED, but as the LED gets more power, the signal coming out of the signal generator collapses. So technically we're putting about a half volt peak to peak into it and getting 1.7 volt across the LED. Now, while we're doing this, let me sweep the voltage. You can see the current that the oscillator is using really isn't doing much of anything. Now at 1.3 volts, the LED's barely lit, which is about right. 1 volt's about where this triggers and comes on, and you can clearly see as I play with the frequency coming in, we can get different voltage. Now it's also find nulls in where the maximum power is, and in the meantime the power, the voltage coming in is it goes through a series of nodes here. Now turning off let's put it back up to max resonance here, and the voltage about 1.7 volts. Let's turn off that 1000 hertz modulation that I put in. Okay, the LED doesn't light, and yet the voltage is over 2 volts. Okay, the current dropped because we're not using the 1000 hertz modulation side, and this is on max gain, but it's off right now. But the voltage across the LED is according to this is 2.2 volts, which is really a lie. This is, if I could put a portable scope probe across this, we'd find it's just pure RF. So I'm not able to really measure this. When I turn on the modulation, LED lights back up. the we're back where we were. The current goes back up. Now if I unplug the unit from the AV plug, the current stays the same. Of course the LED is not lit and there's no voltage. And when I plug the AV plug, its current really didn't change at all. So there appears to be something with this pulse of the modulation is doing something, and it's just 1,000 hertz pulse with this 100 megahertz signal. And now I'm going to try different LEDs after I create a power curve for based off of voltage I'm measuring, which correlates with the brightness of the LED. So as a gauge, it's useful for brightness. As actual voltage reading, it wouldn't be, accurate. And also based off of a peak-to-peak coming in from the signal generator. Also, we need to try different LEDs. I suspect different LEDs may have different frequencies. Also need to play with different modulations here. I can see as I just pulse it by hand, just kind of ramp up the voltage, that I can get different layers, levels of brightness and different voltages. So there's something with the pulse modulation that's triggering this effect. One other thing is this antenna isn't really even needed. And also, if let's go ahead and unhook the voltmeter from here. It's just running naked right now. There's nothing going on. And actually, let's go ahead and unhook the oscilloscope. It changed the frequency of where it becomes brightest by about 10 megahertz. So the earth ground changed a little bit, but not much. So we're running naked right now. Let's go ahead and unplug that, and you can see it's still lit up. So some food for thought here. Thanks a lot. To add one more thing, so you can see the modulated 70 to 100 megahertz signal modulated with that 1,000 hertz signal here. I've got the scope set to 0.5 volt per division and 0.2 millisecond period here. So I'm going to start at 70 megahertz, and we're at like 1.5 volts across that LED. And I'm going to turn it up to the max brilliance of the LED, which is around 100 megahertz. You can see that the input voltage starts to clamp down as I move up in frequency. And of course, right at around 100 megahertz, everything shuts down because my oscillator poops out. So at max brilliance, this is the voltage coming straight out of the signal generator. And I'll go ahead and put it on the ground. Now, flaky stuff with this cable. Maybe I need to check this cable, but there we're at max brilliance, right at the top of where the oscillator can go, and also where the oscilloscope can travel. And at that, we have the 1.7, 1 volt. Of course, me introducing myself into the circuit can raise the voltage a little bit. None of this affects the current coming in, though. It pretty well stays right at 24, 25 milliamps. Okay, well, food for thought. Okay, here what we have real quick, just to prove or disprove something. I just hooked the LED directly up to the signal generator. I put the voltmeter on AC because that's all it's going to measure is AC. And current's still the same. Modulation cranked, everything's still the same setting. And as I dial through the frequencies, you can see the AC voltage changing. It's all less than 0.2 volts. LED obviously isn't going to light. Put it on DC settings, and of course it's not going to measure because it's just pure AC. Now, getting back to looking at the RF signal, as I change, we had the same attenuation of the signal, which is no doubt has to do with all the mismatch impedances going on here. So the previous videos that showed the gain going up and down, that wouldn't be very accurate. Let's turn the time base down to look at the signal raw coming out of the signal generator. Sweep through the frequencies and you'll see they too shrink and grow. That's 0.5 volt per division we're looking at here. This was a point of resonance with the AV plug-in. So, and of course, like I said, in DC you can't measure it. Current still stays the same. So with the AV plug lighting the LED, there was no measurable current draw at all.